Okay, welcome to the first hands-on session. I'm going to do the first elementary geometries for our aircraft model. So here I have downloaded some pictures from the net in order to help me decide which geometries which should be prioritized to do first. So this is going to be my pen and paper. So one thing which is apparent is that we have some kind of a straight line going from the start to the end of the aircraft, and let's just make this a little bit thicker. So I would say just creating a line which goes from the tip to the end, and as you can see there is some offset. If we go from the tip of the nose here, there's an offset to the end, so probably the height here and also the position of the nose is something which will vary. But I think we could start, in either case, we could start with the line to begin with. So remember, we'll make it simple and then later on we can add on some details. So this line will be one important geometry. Another point will be to, let's see here, it's for the wing placement. So where to place the wing, and this could be in practice it's not necessary to have a separate line, but it's easier to visualize it with a line. I'm going to put a point on this line to place the wing. And then we have the horizontal tail, which can be also placed on this line, the position of it. And then the vertical tail is, as you can see, at the end of the fuselage, but probably it has some kind of offset. So I'm going to put some offset from the leading edge of the vertical tail, where it should start. So from the end of the fuselage to the leading edge of the vertical tail. And then we can see another aircraft, the horizontal tail is actually placed on the vertical tail. So that will be references which we need to provide on the vertical tail as well. So sometimes the user can choose a horizontal tail, conventional horizontal tail, or a T-tail. The same thing goes for the engines. So on this aircraft we have the engines placed on the fuselage. So then that will be a placement on this line basically, while it will also have references on the wing. And we're going to build this, we won't build one big skeleton model. That will be too much, too many details, too much. So we need to break it down into elementary parts. So what we're going to do is that we're going to start off with the skeleton of this fuselage. So I can remove this for now. So the only things that I will include in today's session is a very rudimentary fuselage design, basically points and lines, and then placement for the wing, placement for the engine, placement for the horizontal tail, and placement for vertical tail, and also placement for possible engines. And then I think that's going to be it for today's session. All right, so I will start by creating a new part. Okay, and then I make sure that enable hybrid design is not clicked in. I'll just go ahead and give it a name here. I will call it fuselage. So one important thing to remember is that I am doing this the way I think is appropriate. It doesn't necessarily mean that it is the appropriate way of modeling. Create a geometric set. I'll begin by putting a point on 0, 0, 0. Rename that point to point start. And then I will create another point based on the first point, and then I'll move this point to, let's say that we have an aircraft which is 20 meters long, maybe some kind of a business jet. There we go. Then just press the yellow button here to move out. So if now I have my points here, then I can create a line between these 2 points like such. Press OK. If I press with the middle button here, then my rotation point, and just press and release, then my rotation point will become in the middle here. And now if I press middle button and the right button on the mouse, then I can rotate my model. If I release the right button, I can zoom in and zoom out. Usually this is something which we show you during the lab sessions. It's not that difficult, but it's difficult to explain over a video. There are a lot of helps on the net if you search how to navigate with the mouse in CATIA V5. So now what I will do is that I still simply will take another point, and then I will put it on this line. Immediately I will get on curve. I will put a ratio of length here instead of absolute length. So now it's 17%. I will make it 20, maybe 30%. And then I want it to start from point start. Also I want to change this point name to point end. And then this will be wing position. Like such. And then I will do another point. It will start point start, and then it will go to, this is for the horizontal tail. Let's say it goes to 80%. There we go. We call this horizontal tail position. And then I will create yet another point, again on the curve, but I will choose the end point, and I will have to reverse and choose maybe 0.2. Yeah, something like that. So it gets this, for just to, so they're not colliding. Here's the, for the vertical tail position. Tail position, like such. And then I want to create yet another point for the engine. From point start, let's say that this one goes to 0.7 or something. There we go. So when it comes to the engine and the horizontal tail, they will necessarily not have a component connected to them. So it's a possible position. It depends on how the user wants to configure the aircraft, but that will become clear later on. Okay, so now I have my most important geometries, I would say. We're up in 1, 2, 3, 4, 5, 6, 7. I want to say that another important point is, let's say, coordinates here, and then we'll take that point 0, and then I want to say that this becomes the nose tip position, and let's say that it goes down 500 centimeters down, minus 500 centimeters. Nose tip, and then let's say that we have some kind of a position for the end of the cockpit. So this 0.1 is good enough, and then from point start, cabin end, like that. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Then we can have 1 point for the end of the aircraft as well. Coordinates from this point, and let's say, for the sake of it, this one goes up 500. Something like that. So tail end. Okay, now I have my 10 first geometries. I would say that these are the most important from my perspective, and as I have mentioned before, there are many right ways of doing this. I would argue that this is one of them. And I think this solution is a good solution, because now if I start changing the point end to say 15 meters instead, then all my points will follow accordingly. So this is a robust way of building my skeleton model for my fuselage. Okay, so now we have built the main points, and now I would say it's time to start filling in some more geometries in order for us to be able to connect other parts through instantiation to this fuselage. So I will create a new geometric set, which I will call wing geo. And here I'll create a new point based on the wing position. And the thing is that the wing position can also alter from a Z perspective, so it could go down, maybe even 1 or 2 meters or whatever. So this will be the starting point. Then the wing will have a direction, and I would say that direction is we can assume that it is parallel to the fuselage direction. So now we got the wrong. Let's see. And then point. So we have point, and then we have the direction. And let's say that the wing chord is 2 meters. Something like that, maybe even 3 meters. All right, and then I will also create an endpoint for this root chord on one. So now I have a start and an end for the wing. I can start naming these. So wing start, wing end, root chord. Now I'm going to create a profile. So then I will just choose this point, and then I will give it the direction upwards. If I go to show parameters, I can change the tangent tension to 1, or actually I will take it to 0.3 or something like that. And then I will choose this point as my next point. And then you can see I have a tension 0.3. I will just take and copy this spline, and then I will go here and I will just reverse the tangent. Okay, and then just to make this a little bit aesthetically appealing, I will change the tension to 0.2. Then it will somewhat look like an aircraft profile. It's really not, but it can later be replaced with something which is actually real. So this one, spline wing up, spline wing down. Okay. Now we have the profile, the start, the end. Now we need to, let's see, we also need to give it the direction. So which direction it should go. Here I'll say that I go with point, angle over to curve. So the curve will become this one. Support will take XY plane again. And then this will become the point, reverse direction, and then minus 45 degrees. Reverse direction, minus 20. No. Okay, so we have the shape of the root chord and the direction of the root chord that is done. So we have a lot of things that we can reuse. So I want to take the same geometry for my horizontal tail, so I don't have to recreate these geometries manually. So I will do a manual instantiation. So I will create a power copy. I will take these geometries that I want to reproduce. Then it tells me that I need to give it the wing position, a line, and then XY plane. Sure, I press OK. I create a new geometric set. I call it here horizontal tail geo. And then I go to my power copy, right click, instantiate. Now I don't want to give it my wing position because I want it to be placed on the horizontal tail position. So I click on this point. The line is still this one is relevant, and XY plane is still relevant to be this one. Then I press OK. So now I get my horizontal tail geometry, but this one will need to be a little bit smaller. So let's say that it's like 1 meter long or something. Not 1 millimeter, but 1 meter. So a little bit smaller. All right. So then that's for the horizontal tail. I need to do the same thing for the horizontal tail. So then I create a new geometric set. I call it VT Geo. And then I go to my file copy and then I do an instantiate. And now instead of wing position, I will choose vertical tail position. And the line is still relevant, it's still on this direction. XY plane, on the other hand, is not relevant anymore, because before both the wing profile and the support for the direction was placed on the XY plane. Now the support will be put on the ZX plane. So we'll take ZX plane instead, press OK, and here we have our vertical tail, but the placement is off. So I will just choose another placement for it. Let's take it up for upwards 1 meter, something like that. Also, I mean, let's just make this more aesthetically pleasing. The wing end maybe should be maybe 5 meters. Yeah, makes more sense. And then horizontal tail becomes something like 2 meters maybe. Yeah, that's okay. And the vertical tail is fine as it is, but we'll change the position. So that it's placed 0.50. 0.18, yeah, something like that. So now we're starting to get something which kind of looks like an aircraft skeleton model, but there's still a lot to be done. But now I am confident that we can work with this. Okay, so from here we need to start creating more parts for wings and horizontal tail and vertical tail. So what I'm going to do is that I'm going to start up a new part, and then I will call it wing power copy. Press OK. Now we'll go back to the fuselage part, which is the most parent part. Here all the references start from here, and then I will take this reference, this reference, this reference, this reference, and this reference, also this one. However, before I need to change the name of this one, it's a leading edge line. And then I will just make sure that the other ones have exactly the same name. There we go. Now we'll take these geometries and I will paste them here. Here you choose as a result, because we don't want any specific link to the previous part, because this is not the part which will be connected. This is the part that will give the power copy. We'll come to that later. So we will call this geometry set references needed, and then we will call, let's just move the window again. So we will create a new geometric set. I will call this geometry only. Geometry. That is enough. And then I will just reorder children, and then I want to have geometry in the bottom here. And not that it matters, but yeah, aesthetically it would be weird to have the references in the bottom. So now I have these geometries. I will press this here, and then here is the references that I have. So what is left for me to do is to start creating. So what I will do now is that I will firstly create some parameters. I press here the FX button here, and then I will create some parameters. We need a parameter for the length of the wing. We need a parameter for the angle of the next wing, and then we need a parameter for the tip chord. Let's see, do we need any more parameter? Let's start with that. Properties, the name should be wing length. and this one is LE angle, and this one is tip chord length. Wing length, let's put it to maybe 5 meters. And this one we can put 20 degrees. And this one we can say 3 meters. All right, so now I will create a new line. This will be my leading edge line with the correct length. So I will choose this point, and then I will have a direction which will be this line, and then it will be right click, edit formula. We'll take the wing length here, and then sorry, let's see here. Yeah, press OK, and then I can hide this one so it doesn't disturb me. All right, now I will create a point on this line, ratio 1. Now I have a point here. Okay, so now we have length to our wing, and to play it smart, instead of recreating these geometries, as you remember, we did a power copy here for the wing. So what we're going to do now is to just I've created a geometric set which I called wing geo, and what I'm going to do now is that I'm going to instantiate from selection, and then I'm going to instantiate this power copy. The wing position will be here, the line will be here, and then the plane will be XY plane. Then press OK. So now I have the tip chord of the wing. And what I'll do now, there will not be a, we don't need a offset here, so it should be connected to the leading edge. So I will just put value 0 here. And then let's see here, then we have the root chord here, and instead of this value I will edit formula and then take the tip chord length here instead, as such. So now I didn't have to recreate a lot of geometries here. Then I'll go back to this geometric set, right click, define in work object, and then I will connect this part of the wing to this part of the wing. Now I have my trailing edge of the wing, and just to make it more aesthetically pleasing, I will also go ahead, select the multi-section surface, click on this spline and then this spline, and then I will choose the leading edge and the trailing edge as guides, and then I will just press OK, and I will get my upper surface, and then I will do the same operation for the below surfaces as such. Now I have my wing. All right, so what will happen is that when we are going to instantiate this wing, we will need these references, and then this geometry and this geometry will be instantiated. The good thing is when we instantiate these two geometries, then we are all set for another wing to be able to instantiate upon that, because we have the same references here, even the names are the same as the ones that we have here. So this we'll get back to this later on. So what I will do now, we can just we also need to connect the leading edge line, the angle, edit formula, then here we take 90 minus 20. Oh, my bad. 90 degrees. Was this not correct? Minus 80. Oh. Then we have to take I have a brain freeze right now. Minus 90 plus 20 degrees. I think this should be correct. Let's see. So if I take 10 degrees and it goes like this, and 0 degrees it becomes like that. Yeah, no, this seems to be right. And then 40 degrees becomes like that. Yeah, perfect. So let's go with 25 degrees. All right, then this is all set. And now I will create a power copy. And then I will select this geometry, and this, and this. And then it tells me that I need these references. I don't particularly like that it has also chosen the XY plane, but that is due to the fact that we didn't include it in the references needed before. So because I want to have all the lists that I have here, I want the same to be shown here. So I'll do like this. I'll take OK here, because this is probably a mistake that you could also do. So bear with me for a second here. So what I'll do here now is that I will just go to the Wing Geo, and then I will just take XY plane and then paste special as result with link. And then I can name it like plane W. And then I'll take just the same for the horizontal tail. But for the vertical tail, it's not the XY plane, it was the ZX plane, as you may remember. Place special as result with link. And then we will call this plane W as well. And then I will copy this one, go to references needed, place special as a result. So what I will do now is that instead of using this plane, I want to use this plane. So the trick is to right click on this plane, go into parents and click replace, and then choose this plane instead. And then if we go to power copy that we have created, now we have the equal amount of references needed as we have here. So wing start, leading edge line, wing end, the 2 splines, the RC line, and the plane W. That's perfect. And then I will just click OK here, and then I want to change the name of the power copy to just PC. And now I am done. So I will save this part. So I saved my parts. Now I'm going to create a new product. And I will call this product, just aircraft product 1. And then I will also save this one, save, and then I will include my fuselage part here. There we go. All right, so what I will do now is a process, the manual process for instantiating. And what I need to do is that I need to first place a part. Then I need to manually change the name of the part to, let's say, wing 1. And then I need to go inside this part. Then I go to fuselage, I go to the wing geo, and then I will copy these references and then paste special. Here I would want it with link. So I place it, paste it with link. Now I have my references. What I do now is that I go to instantiate from document. I have my wing PC here. Double click. Now I have a set of references that I need to select in order to get my wing instantiated. So I'll take wing start, leading edge line, wing end, spline wing up, spline wing down, RC, plane W. There we go, and then press OK. And now we have a wing. And we may play around with the parameters here and see that it works. Yeah, and this is this angle is for the next wing basically. And then the tip chord length we can change as well. Everything seems to be working. Now, when you do a manual instantiation, a weird thing happens is that your geometrical sets go into your part body. I'm not exactly sure why this happens, but when you're working manually, it really doesn't matter because you can just like place them out later. But when we do this with code later on, they will be placed in a correct way. So don't worry about it. And now we have this wing geo. So what I want to do now in order to demonstrate how rational this technique is that I will create a new part. And then I will just change the name of the part to wing 2. And now I will go inside wing 2 and I will, oh yeah, this is something which I missed. So what I missed was that I need to also have the plane in this geometry. So what I need to do here is I need to take a plane and then select this one as a reference, and then 0 here, offset from plane, and now I have the same plane here as well. and then I need to call it the same. It needs to have the same name, plain W. There we go. Now I'll save this, and then I need to redo the process. So what I did is that I just reinstantiated everything so that I have the right references in my Wing power copy as well. So now I have the next Wing part ready. I will copy the references from this Wing part and then just paste them here as result with link. And then I can instantiate the same power copy again, but now on a new set of references. So we take wing start, leading edge line, wing end, spline up, spline down, RC, and plane. Then we get the next wing. And this process continues. So now I have yet another reference geometry which I can copy into a new part, and then and so on and so forth. We can just instantiate it upon instantiation. I'll just decrease this one and then change this one. So this is still very basic. I don't want to put too much details in it right now. It's better to get a good holistic overview of the product before we start detailing. So what I will do now is that to show you how this actually is put together because of the external references. If I would change the leading edge angle on this wing to, let's say, 40 degrees, then this wing would be modified. Or if I will change the wing length and then update, then it would update this part as well. Any case, it's not stranger than that, and then I can just continue creating the same, doing the same instantiation for the horizontal tail. I just need to go to the right references, paste special as a result with link, and then I do instantiate from document, wing, power copy. So you see, we just created one geometry, but then we are reusing it everywhere. Wing ends, line up, down, RC, plane W. There we go. And then change the length to 3, and then tip chord to 1.5. And then the last one is for the vertical tail. Forgot to name this one. Let's call it HT1. So it doesn't make sense to put in more horizontal tails. Usually the horizontal tail is not more than just one section. The same goes for the vertical tail. So, but I mean, you still can use that power copy. You just don't need to keep on adding more parts. I will just paste in the references here, and then I will do instantiated from document, wing PC, and then we're at it again. So a big difference now is that the plane here will be for the ZX plane, this one, instead of the XY plane. So that will ensure that we will actually get the vertical tail on this direction instead of this direction. Like such, and then the trailing edge will be 2000 or something. Leading edge angle will be steeper than this. Oh yeah, the leading edge angle is actually defined in this part. There we go. All right. So this will be it for this session. Now we have created a good structure in order to start instantiating our aircraft shapes. For the next session, I will complete more of the fuselage geometry, work more on the structures. But most importantly, before we do any of that, actually what we need to do is to start working with Visual Basics. So it's the Visual Basics lecture, and then we're just going to do exactly what we did now when we instantiated manually. We're going to instantiate automatically. So I will do automatic instantiation for this wing template for the next session. The session after that, we will put in more geometries and also the structures of the aircraft, the ribs and the stringers and so on and so forth. All right, so thank you for taking your time. I hope that this session has been useful for you, and if there are any questions whatsoever, please put your comments in Teams. Have a good day. Bye.